Remember, this is a math course. Before mathematics was a subject, it was called something else. It was called logic. Everything we do in mathematics first started from the philosophy of logic. It was a philosophy course. So that's how we're going to start off the math part of this course, is understanding where did it all come from. Because if you think about it, logic, well, what is reasoning? How does it relate to logic? What is reasoning? How do they relate? Reasoning and logic. What's that? Which one's that? Okay.
Like explaining the one?
Both of those are true, yes. Because reasoning is you eliminate all the possible wrong answers, wrong steps. You're reasoning through this whole process. And you're answering the process, the problem, by going through what are all the possible answers. Okay, again, when you walk in here, always check the back of the table, back of the room. And that's what reasoning is. It's working through the problem, busting what you have. What is logic? You're reading straight out of the papers. No. I want to know what you know, not what I gave you. Because I'm always deliberating, should I give you these packets before the class or after the class? Because I don't want you just to spit out what I give you. I want to see what you know. Because if you know it that well already, you're exempt. You get an A in the course. Get out. But you don't know that. You're just reading straight out of the papers. That's not learning. What is logic? What's that? Facts are just facts. There's no logic involved in facts. But what we'll learn, I wonder what you all think about what is logic. You've heard it before. You're told to use it. But what is it? Yes, you don't have to raise your hand. Just
Something that makes sense, something that makes sense.
to a very small degree. Because think of how things were back 500 years ago. When somebody was sick, what do? How do they fix the person who is sick? Okay, what did the doctor do?
They do tests on you?
Not 500 years ago. It's if they had the leaves. Let's say you had a cold. Your body temperature was high. What do? The first thing they did, if you were sick for anything, you were sick because of your blood. So if you're sick because of your blood, let's get rid of the blood. They put leeches on you. They would suck out the blood out of your system and hope you get better. Well, that sounded logical to them. If you're throwing up all the time, that means that back in the old days, they would think, well, if you're throwing up all that liquid, you have too much liquid, so don't give them any more liquid. What's wrong with that? You're very much dehydrated, yeah. Because you need water, not Coke, not coffee, not tea, not anything like that. You need water to get absorbed into your bloodstream so it could move around your whole body and send all the antiserum to whatever is killing you. But yeah, that made sense back then. So we can't really say make sense, because something makes sense until you know better. That's not really logic. When did logic start? When did the subject of logic start? Take a guess. Where? Adam and Eve? Had to start somewhere. You'd be surprised. Logic, how many of y'all ever took a logic course? It's always been here, but you never took it. That's the same as back then. I really think that every student before they start college should take a logic course. You see how things are connected. You ever hear people name Socrates, Plato, Aristotle? You know when they were alive? A couple of thousand years ago. They are the ones who formalized logic and philosophy of logic. That's how long ago it's been. But since then, people thought they knew everything and they stopped studying it. Everything has to have a philosophy behind it. Whatever you do has to have a philosophy behind it. When you apply for jobs at schools, one of the questions the application is going to ask you is, what is your philosophy of learning? Or education? It's always the philosophy, your philosophy. How would you answer that? It's a tough question because one, they're testing, do you know what philosophy is? Two, do you have a philosophy? And three, can you put it down on paper? And these are all things that you're going to have to face whenever you apply for a job teaching. How do you know if something's logical or not? You don't say because it sounds logical. Don't do that. If you're an electrician and you're wiring a house, how do you know if it's the most logical way to wire a house, the way you did it? Well, the first thing you do is do what at the end? Yeah. Does it work? On or off? Does it turn on when you flip the switch? Does it burn the house down? Those are the basic things you look at. Remember how we related Puglia? The last thing Puglia did in his steps were what? Look back. And not really check. It wasn't part of it, but yeah, looking back means make sure everything is the best it can be. That's what logic tells us to do. Logic breaks down into these two words, two letters. What are they? True and false. Everything breaks down to that. In computers, they use ones and zeros. Electricity or mechanical engineering, that's what everything breaks down into. Logic is used in math because everything you do in math has to be either true or false. Do you want the answer to be false? No. So if you're going along and you ever get a wrong answer, you did something wrong, go back and try it again. That's mathematics. And the reason those two were so connected was because in mathematics, everything literally is pure logic. Everyone in this room, if you use logic, should never make anything less than 100 on any math test, ever. But that's the problem. We were never taught logic. We don't even know what logic really is. We hear the word. In law school, one of the first books we buy in law school is a dictionary. How many times do you guys read something and get to a word, you think you know what it means, but you don't really know what it means. You just read it, you know you've heard it before, and you keep on reading. Everybody does that. But when you do that and you think you understand, but you have a wrong definition of that word, you've just changed the whole storyline. You ever heard the word ubiquitous? Never heard that word? How about conflagration? Well, actually, you were taught these words. In high school, you were taught to read a lot of Shakespeare stuff. He's the one who used the word conflagration a lot, especially because he grew up in London. And London burnt down in a ball of conflagration. What do you think conflagration is? If something burns down, what happens to it? It's on fire. Conflagration means just that. It means it's engulfed in flames, in fire. When you take a foreign language, what book besides the textbook do you have to buy? A dictionary. If you're learning German, German English, English German dictionary to learn the words you're using in that language. Mathematics is no difference. Mathematics is its own language. You have to understand what you're saying there. So with this, in this section, specifically objectives, we're going to cover 5 basic things. What are quantifiers? What do you think a quantifier is? You ever hear the word quantifier? If you haven't heard of it, use logic and figure out what that means. Is there anything in there that looks like you've heard before? Or it could be in another word that you know what it means? What? What does quantity mean? Amount of, a number of. So a quantifier would be what? Again, if you guys want to be teachers, remember, you have to bestow on your students education. You have to teach them something. Your entire purpose in life should be right now to learn as much as you can. If you don't read books, not junk books, comic books, but legitimate books, read articles and papers. If you haven't done that, start. Because the entire purpose of sending our kids to school is to make them smarter than us. If you haven't started that yet, I would easily say find another profession. When the students always ask you why, the second you say, I don't know, you've just lost them. You'll never get them back. So why should I listen to you if you know nothing? So your job is to learn as much as you can, as fast as you can, before you ever take that test to become a teacher. And yes, you do have to take a test to become a teacher. And a lot of people do fail it. They have to take it multiple times, and you have to pay for it each time. And it's getting more and more and more expensive each time. So again, reason tells us that you should learn as much as you can so you can be a better teacher. But if you're going to teaching because it has only 9 months out of the year you teach and you get vacations the rest of the time, find something else to do. Please find something else to do. You should be in education because you want them to learn as much as you're learning. How many of y'all bothered looking at your notes before this morning? Again, is this what you want to teach your students? Oh, I never looked at my notes. I skated through school. Is that what you want your students to think? Or you want them to be smart? Do you want your students to become doctors and lawyers, engineers? Or do you want them to become mechanics? Which is not bad. They make more money than everybody else, but Why go to school? Do you want to be trash collectors? Dog catchers? This is a very noble profession you're trying to get into. Take it seriously. So whenever you get a word you don't understand, break it down to pieces that you may understand. You could extrapolate. What does the word extrapolate mean? Very good. Extrapolate means to extract. Take out bits of whatever you can. Again, if you haven't heard these words, that's because the stuff you're reading and watching on TV or listening on the radio is just that, full of crap. Watch the news, listen to BBC, watch documentaries, learn something. So quantifiers and their effects on statements. Oh, we'll learn another thing. What's a statement? True or false thing? Okay, yeah, yeah. A statement is an utterance. It could be a sentence that is either true or false. Can it be both? By definition, it can't be both. Because if it's true, it can't be false. Number 2 of our objective, different forms of statements. Number 3, how to determine whether two statements are logically equivalent. What does that mean? Logically equivalent? What does equivalent mean? The same. What are the first letters of the word? Equivalent. Where have you heard those letters before? Equal. How to develop logical arguments. What do you think an argument is? Is it yelling at somebody? No. That's what the primitive society has broken arguments into. But arguments are simply discussions where a statement is stated and a counter statement to that statement is made. That's an argument. Always logic based. No emotions, no feeling, just logic. How do you determine whether an argument is valid? How do you think that's going to happen? What's that? So how would we prove it? Reasoning and logic. Okay, so how would we use logic in a statement? Oh, I'm glad you said that. What is a fact? Who determines if it's a fact? This was very, very, very well publicized during this last election. If you ever watched any of the campaigning material, it's always one side always just threw out numbers. Just threw out numbers. And people believed it. The other side threw out numbers, and the other side would automatically just try to fact check. Media would do that. Media is very, very one-sided. I mean, that's why I never listen to American news anymore. It's either BBC, European, Telemundo even is a little better. But I mean, it's better than anything American. I never listen, I never watch anything. Even the weather you can't trust. You watch the weather at 5 o'clock, 4 o'clock in the morning. Before you leave the house at 7:30, they've changed at least twice what the forecast is for the day. I mean, if you can't trust weather, what can you trust? So again, if you haven't started listening to news, start listening to news. International news, because they have no vested interest in what's going on. In America, the media is owned by certain people and they have their own things. So is Hollywood. Don't believe me? Look at the shows you're watching now. What are they trying to cram down your throats? Watch what's in every show. You have always a homosexual couple, a mixed race couple. You always have some sort of violence against one of, or both of those groups. Everything's trying to force down our throats in media. The storyline is now politicized. It's up to you to determine what is true, what is false. And that's what I'm hoping with this, we can start understanding what's going on out there. All right, let's look at this. The very top, it says, logic is used in mathematical thinking, reasoning, and sense making. What do you mean by sense? What does it mean? Touch, smell, hear? What is sense making? Or they talk about common sense. Common sense is different than the five senses we have. Common sense is pretty much what we live on. If you walk into a kitchen and you see the counter of your stove is red, what is that telling you? It's hot. Don't touch it. If you see steam coming from a pot, there's what inside that pot? Something hot, bubbling, boiling. That's common sense. Logic, on the other hand, is what we use to try to keep away from adverse scenarios where common sense doesn't play a big role. In logic, statements in a sentence are either true or false, but not both. There is a scenario where it can be both. Everything I say is a lie, even that. That's called a paradox. A paradox is a statement that is both true and false. You could also say, since it's true and false, it's neither true nor false. How can everything I say is a lie, even that? How can that be true? But then it's false. And I said, I admitted that in there. So that statement's true.
Oh,
Well, yeah. So the paradoxes are out there. Actually, it's another thing. In law school, the lawyers are taught to ask questions to trick you to answer one specific way. Actually, so are media people in an interview. For example, so Mr. Jones, have you stopped raping boys? Think of that question. It's a yes or no question. Have you stopped raping boys? What's your answer? Either way, you've just incriminated yourself. And that's what they do to trick you. If you say yes, that means you were, so arrest them. If you say no, that means you're still doing it, so arrest them again. So you have to be, those kind of things you have to be very, very careful about. The media is very notorious for that kind of stuff. If they don't like you, they'll try to corner you and give you something so they could hang you with. Again, I feel sorry for you guys being so young right now. How many more elections you have to go through? God, I feel sorry for you. Every 4 years, actually every 2 years for House and Senate. Well, House, Senate is every 6 years. So every 4 years for president. I feel sorry for you. You guys have to put up with this crap, these lies, innuendos, and just everything's false. So whenever we talk about statements, those are going to be lowercase letters. In mathematics, in logic, there's, again, it's a language. It has its own defined items. So if you see something represented in lowercase letters, that's a statement. That part can be either true or false. And a set of statements, the whole set of statements, are represented by capital letters. Now, how does this relate to mathematics? This is the stuff you guys have seen before. It's a capital letter, so it represents a set. Sets are defined by brackets. What's inside the set, these elements are my statements. So this says the set A is made up of the integers 1 through 5. Set A, this set A is defined by the integers 1 through 5. Remember, these are all my statements. Statements can be either true or false. Is number 1 within 1 through 5? Is 3 1? Yes. So this is how logic and reasoning all relate to mathematics. Is that a statement? How do you know it's a statement? That's one. Very good. What else? It's either true or false. Statements are either true or false. Is today Monday? True. If it's not, then it's false. So that's why we know that's a statement. That a statement? It is raining? Yeah. Lowercase. Is this a true statement or a false statement? Okay. A statement can be either true or false. So therefore, it is a statement. I am a student. Is that a statement? You're either a student or not a student. Red is a nice color. Remember, whenever you answer the question, you have to tell me why you answered that way. Is it a statement? So you know there's two things you have to check. Is it a lowercase letter? Yes, that's a check. Is it a true or false statement? Why not? Very good. Very good. Nice is an opinion. Some people don't like it. Some people can't see red. Don't believe me? Sit at any intersection and watch when the light turns red. See how many cars fly through there. They don't see red. Here's some more examples. She has blue eyes. Is that a statement? Ooh, one table has a yes and a no. It's a paradoxical table. Is it a statement? Okay. Who is the she they're talking about? If you're in a auditorium and you say, look at her, where are you going to look? That's not a statement. It's a false statement. I can't prove if it's right or wrong. Is that a statement? Why?
Because you can plug in an answer for X and it's true or false.
But I could put a number in there and makes it false. You could put one that's true, so it's a paradox.
It just keeps going until you do get it.
So that means it's not true or false. It's true and false. So this is not a statement. Because remember, it can only be true or false, not true sometimes and false sometimes. It's either going to be true all the time or false all the time. So that's not a statement. Because if I give you an X, if I give you 3, does that work? So it's not a statement. If I give you 12, no. If I give you 11, yes. So it's not a statement. It's got to be true or it's got to be false, not conditional. Is that a statement? Why not? It's what? Is it even an equation? What's missing? The equal sign. So it doesn't equal anything. I can't tell you if it's true or false. It's just 2 plus 3. Look out. Is that a statement? No. Look out is an expressive term that doesn't even tell us anything. Look out for what? If you intend somebody to hide behind the cover, what have you just told them to do? You told them to do the opposite. You told them to look out, and then they'll get injured. So that's neither. X plus 7. What is that? What symbol is that? Greater than. X plus 7 is greater than 11. Is that a statement? Why not? Don't know. Yeah. X could be true or false. So it's not a statement. Not a statement. This goes back to English. It's a what? It's a question. Can questions be true or false? No, they can be valid or invalid questions, but they can't be true or false. Lincoln was the best president. True or false? Some people think yes, some people think no. What defines the best president? Did he play the best basketball? Could he shoot the best? Did he make the best laws? You don't know. So obviously, we can break down with what we have these examples. First off, they can't be questions. They can't be expressions. and they can't be math equations. In logic, you have, when you make a statement, you have to be able to negate it. What does negate mean? Yes. But to negate something means, you said opposite of true, is to make it false. Or if you go further, it's to change the truth statement from one side to the other.
It's false.
Right. Like, for example, it's not a pretty day today. First off, that's not a statement because pretty is subjective. Let's use, it's not a warm day today. What would be the negation of this? Yeah. It is a warm day today. Get rid of the not. Negation, to negate something, introduces the not statement. So if I give you a statement, P, just remember, lowercase letters are statements. So I don't have to write anything more now. I'd say this is a statement. It's lowercase. Whatever statement you want it to be. The negation of it is not P. We use symbols for this. Instead of using the word not, we use the tilde symbol. Whenever you see the tilde symbol, that means it's a negation. Where have we seen this in mathematics? That's my statement. That's my negation of it, the opposite of it. And this goes on further to our commutative property of addition or our inverse properties. Three plus -3 is what? 0. It negated it. If you give me 3, I take away 3, I just negated the 3 you gave me. That's what negating does. So, if a statement is true, is negation is what? Yeah, is not true, which is false. Remember, the negation is the word not. The rain is falling. What's the negation of that? So this is my statement, P. What's my negation of it? Very good. Can you say the not rain is falling? No, it didn't make any sense that way. So again, then we have some reason that we put in here. Example 1. Negate the following. Negate that. If you're having difficulty, let's put it into words. 2 plus 3 is equal to 5. That's my statement. What's the negation of it? 2 plus 3 is what? Not equal to 5. Is not equal to 5. Remember, the word not negates it. A hexagon has 6 sides. So what's going to be the solution there?
Hexagon does not have.
Yep.
six sides.
A hexagon does not have 6 sides. Next on your sheet, you see quantifiers. So the negation of it. I left that statement in there for y'all. A statement and its negation must have opposite truth values in all possible cases. This is a negation. The statement and its negation must have opposite truth statements. We'll look at these in a second, what that really means. Quantifiers. Are there any words that represent an amount of things? Besides 4 of, 5 of, are there any more general ones? That's a question. No, that's not giving us, it's comparing to. All, none, some. Those are examples of quantifiers. It says, how many? These are a lot more complex to negate because we have to know what the opposite of these things are. And on your sheets, these are the words that we use. So we have something called the universal quantifier. Universal, that means everything. Those are words like all, none, no. So it's everything in your set. It's universal. Existential quantifiers. When we say this, some. Besides the word some, we could said at least one. And that's going to be pretty important in a little bit. At least one. What are the ones? All, every, and each. Again, all of these words, these quantifiable words, and the words we use in the truth statement, we'll show you in a little bit, all relate to mathematics. The operations of addition and multiplication are also expressed in these operations. All right, so some students at Mountain View have brown eyes. Is that true? What would be the negation of it? Remember, if you're looking at, this is where it gets interesting. Look at the very bottom of your page. You have the statements. Here's your statement. Here's its negation. Some X are Y. The negation is that no X is Y.
Students do not have brown eyes.
Well, the statement is some students have blue eyes or brown eyes. The opposite of that, no students have brown eyes. Because what does some mean? Not all. So the only thing opposite from that is no students have them. Because you can't say some other ones, though. No, that's just playing back into this one. Some X are not Y. Some X are not Y. What do you think the opposite of that one is? And why? Because if this one is is no, that means if this is a negated one, then this one says all X are Y. Because it's negated. This one says some X's are Y, some X's are not Y, means that's the opposite of this. It's negated. So we go from no to all. all X are Y. When you negate something, it doesn't mean the exact opposite. Give me something that's not all. Some. All X's are Y. The opposite of that is some X's are not Y. And this one is no X are Y. What's the opposite of that one? Some. Why is it some? Besides you reading off the paper. Again, if you answer the question, you have to tell me why.
Stating the amount of X being Y.
Well,
that X and Y are not.
how would you prove that something is no? No means there's nothing. What would prove that wrong? If there's one at least. So if there's some that X's aren't Y. So we have to just negation of no. What's the opposite of that? It's not really all. It's not really that binary. It's to negate no X is Y, no X is Y, then some X's are Ys. These will take the longest to memorize. Because we're not used to think that. We were taught that if it's all, the opposite is none. If it's no, the opposite is all. Where's everything in the middle? To prove a statement wrong, you have to just find one example where it's wrong. Let's look at the next example. Example 2. Negate the following. A. All students like hamburgers. What's the negation of it? Very good. Some students do not like hamburgers. Some people like math. What's the negation of it? No people like math. There exists a natural number n such that 3n equals 6. What's the negation of that? Look at your example that we just had. If these are true, that means if I give you this statement, the negation is this one. You can go both directions. So for this one, look at your sheet and what's the negation of that? Go from right to left this time. There exists a natural number n such that 3n equals 6. For all n, 3n equals 6. Or does not equal 6. For all n, 3n equals 3n. What's the negation of that? Yeah, there exists a n such that 3n does not equal 3n. For the universal ones, the all none, you just have to find one that's not. Let's see, some prime numbers are not odd numbers. First off, what's a prime number? Yeah, numbers that are only divisible by one in itself. We'll talk about that later on in this course. What are odd numbers? What are odd numbers? Numbers that are not evenly divisible by 2. Right. But you can't use, yeah. Your answer was what everybody thinks in their head first. But now in this class, we've learned we can't just say that. So what's the negation of that? Very good. And that's a true statement, because if it's an even number, that means it's automatically divisible by 2, which is not 1 or itself. So that's a very true statement. Again, that part's going to be the most difficult part to learn, the negation. Now we're going to do something more fun. Truth tables and compound statements. Truth tables are how we're going to prove the validity of a statement. Let's just jump straight into there. So we have a statement. Remember, we define it in truth tables. We have to take the statement, whatever is given, and assign it to a variable, a statement variable. So the statement we're given is, it is hot today. Instead of using all those words, we define it as a letter. The truth tables look like this. So first thing we're going to look at, here's our statement, which we're going to use P. This is our statement. That's statement 1. And well, in this one, we'll use a negation. So how would you write the negation of P? So since our statement is P, what are the possible truth outcomes for P? What are the possible outcomes, the truth outcomes for P? It's either going to be true or false. It's always, it's the only thing it can be. P cannot be anything more than true or false. What's the negation of P? What's the negation of the first one? False. What's the negation of the second one? So this is how we're going to do that. We're going to start taking, like we do in mathematics, we're going to break down each statement that's being given to us and create columns for our truth statement. Typically, the most common ones we talk about are and or statements. What do you think a compound statement is? What is a compound statement? No, compound statement means two or more. A compound statement, we have two or more statements inside there. So let's pretend our two statements that were given are P and Q. Those are my statements that are given. The reason I don't write what P and Q are, just so I give you a statement like it is hot today. That's P. It is raining outside. That's Q. So, but I don't want to write all this stuff down. So I'm just saying that P and Q are my statements. So the truth table always start off with what you're given. You're given the statement P and the statement Q. What does the word and do to a statement, to two statements? It combines them together. Yeah, so the symbol we're going to use for the and statement is the arrow up. What's called a caret. You'll see it on your keyboard. It's like something like shift 6 or shift 7. It's the arrow up. So the statements here is P and Q. So we're looking at the and statement. What are the possible outcomes for P? P is true or false, and Q. So now, since P can be true or false, and Q can be true or false, there's two of them here, there's two of them there. 2 times 2, we have 4 possible outcomes. There are 4 possible outcomes. Let's see what they are. They both can be true, or it could be true, false. Or instead of true and false, it could be what? False and true. Or they could both be false. Now, since and means they're put together, it's easiest if you think about it Think of a tube. You have a tube. We say true means open and false would mean what? Closed. So if you pour water in this tube and this is P and this is Q, are they open or closed in this first one? Does water come out the bottom? That's true. That's so if water comes out, that's a true. If it stops, it's a false. How about the second one? P is open, but Q is closed, and you pour water. Will it come out? No. So there's no water coming out. So it's false. How about the first one's closed and the second one's open? Will water come out? So is that true or false? And if they're both closed, will water come out? So there's your truth table for the and statement. You just have to remember that the first one and the second one have to be in the same row. So far, so good. So the and, notice how the and that's why they go together. Now let's look at the or statement. Since the and statement is pointing up, where do you think the or statement is going to be pointing? Yeah, that's a down statement. We have P, we have a Q. Now we're going to look at P or Q. We're going to P or Q. How many possible outcomes are there? 4, because P has 2, Q has 2, 2 times 2 is 4. So there's 4 possible outcomes. They could both be true. I can have true or false, false or true, or they could both be false. Now, we can't use the other one, the and, because the and has both of them in the same row, because they both have to be one and the other back in a row. In this one, here's P and here's Q. Because think about it, it's an or. I can pour water here, or I can pour water here. So if I pour water in both of them, will water come out? What is this going to happen? Yeah, if this one's open and this one's open, water's going to come out, so it's true. How about if the first one's open and the second one's closed, will water come out? Yes. If the first one's closed and the second one's open, it's another true statement. But if they're both closed, nothing will come out. Pretty straightforward. If you memorize these charts, because think about it, or means I could put it in here, or I could put it in here. But the and has to be, I put it here. That's the only one I can have to put both drops of water inside there. Example 3. Tell me, here's this one says, let P be 2 plus 3 equals 5. Let Q be 2 times 3 equals 6. And let R be 5 plus 3 equals 9. True or false? How'd you get that? So this one's a true statement. This one's a true statement. It's a false. So if I have here, I have P is true and true. If true and true, what does that equal? So it's a true statement. Q R. What's that one going to be? What's Q? Q is true. This symbol down is or. R is false. If either of them is true, the whole thing's true in an or statement. Not P. What symbol is that? And R. So the way to do this, what is P? P is true. So we have not true or R is false. So not true is false or false equals false. Those are both closed. Not P or not Q. So we have P is T, so not T or not T. Not T is false or not T is false, so it's false. E, it says not. Remember in algebra also, we learned about using parentheses in the associative property. So we have the not, P is T, and Q is T. What is T and T? True. So not true is false. Again, same thing we do in mathematics. This is where it came from. If you have a parentheses, you have to do inside the parenthesis first. And F says P and Q or not R. This is where the order of operations came in mathematics. What do you have to do first? Do the parentheses. You have to do the parentheses first. So we have true and true or not false. So inside parentheses, true and true is what? What's not false? True. So true or true is the true statement. This is where it came in mathematics, the order of operations. Any questions about this? Example 4. make a truth table for this. How many rows we're gonna have? Because all we're using is what? P. So the only thing P can be is either true or false. Then we have the not P. So the not P is going to be what in the first one? And then we're going to do P or not P. This is the or statement. True or false? False or true? So you see, this is an example of a paradox. The answer always comes out true, no matter what you put in there. Now we're going to look at something called logically equivalent. Now we're running out of time. We'll pick up from here next time. Because we're going to finish up talking about these equivalent statements. And then we're going to look at, how many of you have ever heard of Venn diagrams? With the circles? That's what we'll finish up this section dealing with. All right. So that's it for today. We'll finish this up next time.